Hey, this is John with Two Moose Home Inspections. Welcome to the April 2022 in-service training. If you're new to our in-service trainings, I highly recommend watching this at 2x speed because we have a lot of information to get through. So the first thing we have is a pretty interesting radon story. On our devices, it's clearly stated not to touch the devices, that we are recording both the temperature, humidity, radon levels, movement of the device, a whole bunch of other metrics is all listed right there. Do not touch the device. This is who's doing the radon test. You can give us a call, whatever it may be. Well, there's also a button that looks a lot like a power button on the device, and we dropped a radon detector off at a house, and somebody decided to press that button. And what that really just shows is somebody was really interested in trying to stop this radon test from occurring. Now, contrary to their understanding is that by pressing that thing that looks like a power button, it actually just started a new data set. Not a big deal. We're able to get all of our data because we're always constantly recording, whether or not we're in the middle of a data set or not. And as they probably expected, they had high levels of radon. So the main thing is that people like to touch our devices, our things. We still get accurate readings, and we still are able to tell the person who's buying the house that, yeah, you do have high levels of radon, and that's okay. It's an easy thing to fix. But it just kind of cracks me up that so clearly stated with our name, phone number, what the test is, and all the information about what we were recording, they still decide to press the power button to try to stop the test, and it just cracks me up. But the other thing is, I know we've been talking a lot about Matterport over the past 3 months, but we are almost ready to go. And so what we're going to do is we're basically going to do a soft release of our Matterport service starting on May 1st. And then we are going to, at our next newsletter, make it a big, to-do about the fact that we now offer Matterport as, 3D virtual tours as a service that we do at Two Moose Home Inspections. So we're about 2 weeks away from basically having our soft start or our soft launch, and then it'll be out and publicized to everybody. So the guys have been doing a really good job making sure they have everything that they need. And so I think we're ready to rock and roll with Matterport here, hopefully within the next 2 weeks. And then what you'll see is the hard release date, which will then be following up shortly thereafter at our May in-service training and newsletter. So let's jump right into it. We got a lot of stuff to cover. All right, so first thing first, GFCI protection not installed. Yeah, that's a pretty common one. We go over that quite a bit. But the thing is, I watched a really interesting video the other day, and that video, they took all this stuff. They put a power strip, they put a toaster oven, they put a light bulb, all this stuff, and submerged it in water. All of these devices continued to operate as if there was nothing wrong. It almost gives you the idea that, hey, maybe that water is not electrified. But that's not the case. The water is electrified. At that point, anybody that touches the water that is connected, whether you're spraying a hose, whether you're inside of a container, whether there's a big puddle, you can then be electrocuted. And so electrocution, you're dead. Shock, it just hurts. And so a GFCI makes sure that if there's anywhere that water can be, that it's able to shut off the water, because a normal circuit breaker will not do that, and all it will do is electrify water. And then there's something in this inspection report that we're going to go to about crawl spaces and how it's just extremely important to be very, very careful whenever you're around water. All right, the next thing is a damaged waterproof cover. And so this cover right here is damaged, and it doesn't really seem like it would matter that much, but in the same vein, if you take a look, we have that snow right there, and then we have this cover that is fully exposed. And so replacing that cover is really ideal to make sure that whenever we have driving snow that we aren't getting water making contact with the electrical conductors, which would then cause a shock or electrocution hazard. So again, putting proper covers on things and also making sure that things are GFCI protected, all of that extremely important. So then as we move in, we have our whole blog post here about the different types of covers that we have. And so there's a whole blog post article talking about everything you need to identify all the different all the different covers, whether it be waterproof, weatherproof, whatever it may need to be, or even just those decorative ones. Those are neat too. So then we go into damaged switch plate. So you can replace the switch plate. And again, why does it matter? Well, it doesn't really matter, but it matters enough in the sense that if it's damaged, it could get even more damaged. And then eventually energized components could be accessible to touch. And so you might as well just get it replaced. And does this really matter? No, it's like a $2 repair, not a big deal, but it's one of those things that should be done and should be done right. All right, this is a pretty common thing that we see, which is a fill spout installation that was done incorrectly. So what happens is that the rough plumbing is done, and that rough plumbing will have a copper pipe that comes out, and then you're going to have threading on the end of that copper pipe. Now, if that copper pipe was not measured to be the correct length, then whenever you screw on the fill spout for the bathtub, then what will happen is that you might end up with a gap. And so if we take a look here at the photo, you can see pretty clearly that we have quite the gap. Now, what we have in this particular picture is that we have right here our fill spout, then we have the copper piece, and then inside there is the wall cavity. Now there is a hole that is cut out of that space, which means that water can come down into that hole, and then you can start getting moisture trapped inside the wall, which will then lead to mold growth, which will then lead to basically just the deterioration of that material. And so to protect that wall from deteriorating, we really need to get rid of that moisture. And so right there, that's pretty severe, but you can still kind of seal that with caulking, and I would definitely recommend doing that. So this right here, I just thought was like, funny. Using this Elmer's glue right here to hold this thing open or propped the way that it is. So the thing is that inside that circle that's right over there, that bigger circle should have a plastic insert pushed into it, and then you should be able to have a threaded screw that would then hold everything together. The real issue with this is that if something were to happen, it doesn't actually matter, but let's say something were to happen, one of those covers were to come off, then you could have hot components inside of that furnace now being able to contact combustible materials. And so we really just want to make sure that that things are done properly. So that's why something like that is called out. And how much does that little piece cost? I don't know, maybe $5 because you have to buy the manufacturer specific thing. But really, as long as you have some solution to make sure that there's not a risk of, if it gets bumped, that you now have hot components accessible to touch, then you should be golden. I love the Elmer's glue. I thought it was hilarious. All right, so one of the things is that we have a lot of buildings that are manufactured everywhere, and so there are buildings that are manufactured on site, and then there are buildings that are manufactured that are in a factory or whatever. And a lot of people have this preconceived notion of oh, this is a pre-manufactured or modular home or blah, 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 blah. It makes it terrible. Well, that's not actually the case. What we have found as home inspectors is that whenever we do home inspections and we see a house like this, normally the house is kept to a much higher standard of quality for construction than anything else that is added to it. So normally, whenever you see a house like this, it works great. And then you see the decks, the porches, any additions, or anything that was built by local contractors in that area just being the worst work that you've ever seen ever. And so for homeowners, I just want to let you know that if your house is pre-manufactured, or if it's a modular house, if it came in pieces, that's okay. It's not a big deal, because just by having something built on site doesn't make it any better than anything else. It really matters the quality of the craftsmanship of the person who is building it. So this right here is basically an issue with egress. And so the problem is that, there's a lot of requirements for how many square feet of open space there needs to be, how high off the ground, and a whole bunch of other things of how somebody can safely get out of the house. And with this, the problem is that there's so much snow built up against this window that there's no way, in the case of a fire, that you could easily escape. Now, is it possible that you can open up the window and then with your bare hands start scraping out this snow so then that way you can get in and stand up and go? Yeah, you can probably do that, because you would rather have bloody fingertips than be dead inside of a house fire. Now, the question would be is, can a child say, I am going to remove chunks of ice and snow until I go down to the bone because I know that will save my life, versus an adult's ability to comprehend the situation? But then secondarily, if that were to happen, even as an adult, I can clear out that snow, and you can see that it's pretty icy, especially near that top layer where all of the sunlight hits that, and then it freezes overnight. So it melts and then freezes overnight. And that top layer, even as an adult, if I have to go, could I escape this before I basically die from smoke inhalation? And so really the thing is, this just needs to be cleared of snow, and that just needs to be a part of the normal snow removal procedures. Not only does this have an issue where we could now have water infiltration during the spring runoff season, but additionally, think of yourself as an adult, as an elderly person, or even as a child. Is this reasonable from a safety standpoint to put anybody in this room in case there was a house fire? Is there going to be a house fire? Of course there's not going to be a house fire. But if there were, is it not worth it to just get rid of that snow ahead of time? If you're going to go shovel the driveway, come over here and shovel the window well, or put something in place to prevent something like this from occurring. So anyway, just something to be mindful of. This one here, dryer vent disconnected. I thought this was just an amazing catch right here. And a lot of times you can see whenever this dryer vent is not connected right here to the actual dryer, what you can see is that there's normally a lot of dryer lint and other things like that that just happen to not be caught by the lint trap. And you'll see that all around. And that's normally a pretty good indicator that something is not connected properly. And in this case, yeah, it was not connected properly. Now, I do like some of the things that were going on with this whole area, but in general terms, once you get that connected, everything is working flawlessly. Keep in mind that there is a certain limitation to the number of feet that you can travel. So this 90-degree bend that is happening right over there, basically, whenever you have that 90-degree bend, you're losing 5 feet of total distance. I think it's like 30 feet that one of these vents can go. And so as homeowners, sometimes you'll see that it comes out, it makes a 90-degree bend, then it makes another 90 and another and another. And then that just causes turbulence inside the pipe. And then you can't actually get the air out, and then lint will actually get trapped. There needs to be enough airflow to push that lint, so that way it doesn't settle and then end up catching on fire. So just something to be mindful of there. All right, baseboard's not functioning, and I love this particular view right here. So what you can see, if we look at the bottom here, I have this this dot right at the bottom center, which is like basically just right here. And then I'm just gonna scroll back up, and you're gonna see that I have these other 2 dots right here. And so we can see the coldest spot is all the way over in the corner. We can see the hottest spot is where the sun was hitting the edge, and we can see the temperatures that has. And we can see the point that we were pointing at, which is right here on the register vent, that one is just at 75 degrees. And so we can tell right there that no, it's not working. Now, if you ever see like scorching or anything else like that on one of these baseboard, like right above the baseboard heater, normally that's because the paint will basically be scorched, not catch on fire necessarily, but can be scorched. And so whenever we go through this, we're also looking, hey, is this hotter than they normally are? Is it hotter than the other ones that are in the house? And so not only does the infrared camera allow us to determine if we have an issue where it's not working, maybe it's overly working and is too hot and is actually a fire hazard. So I really do love the fact that on every house that we go through, as we're looking at the in-floor radiant heat systems, and we're looking at baseboards, as we're looking at forced air, we're always checking to see how much heat is coming out and is that, reasonable for what we would expect. So as I was saying before, on some houses, the things that are added to it are just pretty bad. And so we can see it right here. Getting in and out of this house, you're just at risk of this whole stair set toppling over. It is not affixed to the house. It does not have a railing on the backside. It doesn't meet any of the railing or safety standards. It is just extremely unsafe. And then as you look at it a little bit further, you can see that depending on the movement of the ground or whatever, it's not on any kind of foundation. And you can see it, we have like all the snow and ice right down at the bottom of it. And that is basically causing it to be unstable. And then whenever you have a rainfall or spring runoff, then that can just, sink into the saturated ground. And it's just a huge safety no-no. So anyway, all right, here's another really big safety thing. And also, sometimes parents do this on purpose, where they will put a deadbolt where it is basically keyed or, has a key on one side and then needs a key on the other, or has a way where you can't open it from the inside. And they do that because they're like, oh, well, my kid keeps escaping the house. Well, yes, that is correct. The kid keeps escaping the house, but there needs to be another way, because imagine if this particular door, if the key fell out of that deadbolt. So if the key fell out of that deadbolt, then what you need to be able to do is you need to be able to exit the house. So even you as an adult, there's no way that you're going to boot this door down. It's just not going to happen. And so if the key could be pulled out by a toddler trying to escape, then that could be really, really dangerous for the whole family, because there'd be no way for you to escape. And so this needs to have a turn knob on this end, so that way you can, undo it. Now, why does it not? Because some people put 2 things together, so that way toddlers and basically toddlers can't unlock the deadbolt and then escape the house. And that's great from like a practice of, let's make sure the kid doesn't, get out into the outside world without any kind of adult supervision. However, the problem is that if you as an adult need to escape the house and this key just happens to not be there, it's always been there, but then on the day of a fire, it happens to not be there, extremely, extremely dangerous. So just something to be mindful of. So this one I thought was pretty interesting. And what we have going on here, and I'm going to make the other picture a little bit bigger, is that the weather protection is inadequate. But what's really interesting about this is that even if we did have a cover underneath that, so like if there was a cover plate put up against that thing, that's all well and good. But this particular box is not rated for basically outdoor use or weather use. It's not a sealed box, and so where the electrical wires come in, there's a hole. There's actually multiple holes on the back of that box. And so even if we put the proper cover on there, water can still get into that particular box, which is bad. And then in addition, obviously we want to put a cover in there, because if I reach my hand out and I touch any of those electrical conductors, well, then I'm out of luck. And that would be a very, very bad day for me. But all of this was done just so wrong. And there's multiple issues at this particular house with this, electrical that was done by themselves. And I just have to say that unless you're an electrician, or unless you might as well be an electrician because of how much you enjoy learning about electricity and how to do things, you just really shouldn't mess with electricity around your house. It's just not worth it. I mean, if this was done incorrectly, we could have fire hazards, electrocution or shock hazards. And just a whole bunch of other things. Even the way that they drilled into these, basically these floor joists of what was up above, or I guess I would call these rafters, I guess. The way they drilled into that and how much space they took out for the size wire that they were putting in, it's just everything was incorrect. Now, again, does it matter? Yes and no. Take everything with a grain of salt, because the reality is that, just like with what I was saying with everything else, the odds of it being an issue are very slim, but if it's predictable, it's preventable. And so we want to make sure that if we can predict that there could be an electrocution hazard, if we can predict that there might be a structural issue with the way they drilled these holes, then we want to prevent it, because, you know, why not? So then this right here, 100 amp service panel. So the thing about 100 amp service panel is that on this particular house, there are 200 amps going to the house. So this meter is able to take 200 amps. You'll see that because on the meter right about here-ish, right underneath the display, it's going to say something like CL200. And then that means that this is a 200 amp meter. 200 amps are coming to the meter. And then what we have is at the distribution panel, only 100 amps is then going to the rest of the house, which is, you know, okay if you lived in the 1970s, maybe 1980s, maybe 1990s. But in today's modern day and age where everybody has multiple smart devices that are being charged, they have multiple computers, multiple TVs, multiple stereo systems, multiple you know, let's just even say like ranges, electric heat, electric cooling, you know, all that kind of stuff, like air conditioning, whatever. 100 amps is nothing in today's modern day and age. And so 200 amps is really what you want. Actually, I'd say 150 would be a bare minimum. 200 amps would be great. And then you'll see some houses that have 400 amps, and that's because they have like a large home theater system or something else that they know that they're going to be drawing power. And so again, 100 amps doesn't really matter if you only have like one cell phone. But if you are a modern, larger family, then you might run into problems down the line of basically what's referred to as a brownout, where there's not quite enough power to get to all the devices. So something to be mindful of. All right, moisture staining present. So in this case, you see that we have a thermal camera picture. And so the thing is that you can see that there's a little bit of staining on the far side of this picture. There's some staining which says that there was a moisture issue. So if you take a look with the camera, then you don't see any moisture issues. Then what you would do is you take it with the probe and you check with the moisture meter, because sometimes something can be so saturated with moisture that until you actually check it with the moisture meter, you know, you don't actually know, because the thermal camera only shows difference in temperature. It doesn't show moisture. And so anyway, it's just one of those things that whenever you're detecting moisture, yes, you can use a moisture meter, but you wouldn't know what to probe. Yes, you can use a thermal camera, but the thermal camera may not always be accurate. And so you're really using everything that you have to find moisture. And in this case, there was a stain, which then indicated at one point there was some moisture. And so then why are we still calling it out if it was completely dry? Well, the reason we're calling it out is because something happened to make there be a leak. And so what was done to stop there from being a leak, either currently, in the future, whatever? Was there a repair done, or is this a seasonal issue? And so we just want people to be aware, because we don't know why it was happening, because everything is dry and we can't follow it back to the source of the leak. So anyway, then we come on down and take a look at crawlspace water pooled. So a few things going on here. There's a sump pump. Sump pump's not even plugged in. And so that's obviously a problem, but you see all this standing water. Well, standing water is a terrifying thing, because like you can see right here that there are electrical wires that are in the water all over the place. You can see that the electrical wire for the sump pump is in there. And also, like, this sump pump, what a joke. So this was not installed properly. So you see you have that float, and basically whenever the float goes up, then the sump pump turns on, and whenever the float goes down, the sump pump turns off. What needs to happen is there needs to be a hole lower than that grade, and then that basically that float needs to go up to say turn on, and then as the water level goes down, it'll say turn off. And then whenever it fills back up, it'll say turn on. So in order for this to actually operate, the water level would need to be like almost 2 feet higher, which isn't going to happen. So the sump pump was incorrectly installed, was incorrectly plumbed. It was not even plugged in at this point because they realized they're like, oh, it doesn't work, so we'll just keep it unplugged. And you can see that there's like an electrical plug that is like right here where that warning, you know, don't put this near water or whatever, is 100% completely submerged. And so as I said earlier, this right here could be, this water around us right now could be electrified. And as soon as you touch it, your body will just stiffen up and then you will fall into the water and you'll just be dead. You're just dead. And so golly, freaks me out. Just freaks me out. Anytime there's standing water in a crawl space, freaks me out. Now, from is the building safe standpoint, is the building okay? Well, you should never have standing water in your crawl space. So we have a failure of the drainage system around the house. We might have a failure of the waterproofing around the foundation. There's a lot of areas where we could have an issue. Now, is this correct? No, this is not correct. But is this normal for this house? This house, if it was built in the 1970s and every year during spring runoff, this happens. Okay, it's normal for the house. There's no other signs of foundation movement, whatever. Totally normal, fine. But even though it's normal for this house, it's still not right. And so could you do nothing? Yeah, you could do nothing, but you are going to run into risks of mold, which means deterioration of the house. And so yes, you can run into issues with mold, but you could also just do nothing like they've done for the last 50 years and let the issue continue as it is. And then whenever the summer comes, this will be bone dry again, and that's perfectly fine. But what's happening with all that humidity in the meantime? So just really, really scary seeing standing water. Just freaks me out. All right, missing basically cover plate, we'll call it, that there's like a filler insert that would be able to go there. So since that switch is no longer used, which sometimes happens whenever you remove a ceiling fan, and you don't need to have two switches, one for the light and then one for the fan, then what you can do here is you can just remove the actual switch, and then you can just put in a filler plate, and it just covers that little thing so kids aren't putting their finger into an opening that has electricity in it, because that's bad. Don't put your hand in there. That's a bad place right there. Bad place to put your hand. So then we come down, damage moisture inactive. So yet again, they got us. All right, now, here are my questions. How did this happen? How on earth did this happen? And it freaks me out a little bit, because like if you're looking right here near me, if you look all the way over on that side, it just kind of freaks me out, because how did we get that much water? What happened? Was the carpet completely saturated? Was the wall completely saturated? And then if that is the case, did we get moisture inside of the wall, and now inside of those wall cavities, 16 inches on center where the studs are, do we now have a couple of areas that maybe have a lot of mold growth and have a lot of decay happening on the inside? And did the carpet, was it just water sucked out of it? What happened here? I guess that's really what I'm asking. What was the mechanism that occurred? And so, yes, it is inactive, but there are things that are there that make me concerned about why this happened. And so if I were the person buying this house, I'd say to the seller, what happened? And then hopefully the seller's honest and it was like, well, as it turns out, my dog really likes to pee right there. And we replaced the carpet, but we didn't replace the trim. Okay, cool. I'm good with it. If they said, we had a thing and then we replaced the carpet, great. I'm good with it. If they said, yep, there was a water issue, whatever, we sucked up all of the stuff, we dried everything out, and it just so happened that that moisture moved up because this might be a MDF trim as opposed to like a standard, solid piece of wood, then this is what occurred. Great. I'm good with all of that. We had a plant and it was just too moist in that area, but it never damaged the carpet. It was just moist in that area from watering the plant. Great. I'm good with it. So I just want to know what was the mechanism that caused this, because sometimes not knowing is the hardest part. Isn't that right? So then unit leaking. All right, so inside of all of these water heaters, there is a sacrificial rod, and this sacrificial rod basically goes in and allows basically the oxidation to attack that sacrificial rod as opposed to attacking any of the metal components of the water heater. Now, whenever that sacrificial rod ends up being completely consumed, then what will happen is that that we will then get a bunch of decay, oxidation or rust occurring, which is going to completely just destroy this particular water heater. Now, on this water heater, it was end of life anyway. It's, I don't remember how old it was, but it's old. And so with that being said, this particular water heater, you can already see that we now have a moisture issue that is coming down right here above my head. So we have a moisture issue, and so then that could lead to mold, and it's just time to replace it. It's that simple. But the cool thing is that you can actually replace those sacrificial rods, and then you can prolong the life of your water heater significantly by just every 5 years replacing that sacrificial rod, and then you're good to go. And that's something you can buy at like a big box hardware store or local plumbing supplier. So then we talk about ice dams, and if you take a look at this ice dam, it is substantial and it goes down to the house, and this house had a lot of other issues. If you want to know about ice dams, we have a whole series of videos all about ice dams, blog posts about ice dams. We got it all to cover that topic in more detail. Now, here's where the issue is that you can see that we have water seepage through walls. Now, the more that you look into this, what I really think is going on, so we have this water seepage on the wall. You can see the wall is wet. It's 100% wet. And whenever we look at some other walls, you can see that like over here in the corner, it is wet. Now, the other thing that is kind of interesting to me is that at the top of the wall, so all the way up at the top, there's basically what you can see are like 3 white tabs, if you want to consider it that. So all the way over there on the other side of the wall, I'm pointing kind of right at them. You can see these 3 white tabs, and around them, it kind of looks moist. And now what has happened is that we have a foundation wall, and then this is a log cabin build, and we have the log cabin wood on top of that foundation wall. Now the log cabin logs are circular, they are round. And so the water is going to drip around that edge, and it's going to come under, and then it can drip down inside of this space. Now, imagine, you know, hypothetically, let's just say that in the corners here, and like right above my head, you can see, let me pull this down just a little bit more. You can see that we have our foundation wall right here. Then you can see that we have some kind of like insulation or filler right there. And then we have the log just above it. And so I guess I can't do it right there. There we go. All right, so foundation wall, then we have insulation, and then we have log. And so then this log here is round, and so that means that the water can just come around it. And so whenever we look at this stuff, I think what's happening, and again, like in this corner right here, you can see that it looks like that log in this corner up over here is saturated. And I think, imagine hypothetically that there was a whole bunch of snow and ice dams. So here's that ice dam in a corner. Here's the way that the logs are set up on the foundation wall. You can see some snow there. And oh, what does the rest of the house look like? Bam, all that snow right there. And so whenever we're looking at all this snow, I'm pretty confident that the reason that we have this moisture issue inside is because we have all the snow building up. Then we end up during spring runoff season, have all the snow melt. And then because of the shape of the logs of the house, there's no effectively like a drip edge or relief for it to drip off. And then that's why whenever you go back inside the house, you have sections of the house that have a wet inside of the house. Now, is this a big deal? Again, it goes back to this should not be happening, but really, this is not that big of a deal. You can either remove the snow from around the exterior. You can do a whole bunch of things to seal up that space. There's like a lot of things that can happen, but to me, this is not as big of a deal as the other crawl space that we looked at. And basically all I want to have happen is I want like a swale or to, you know, like the ground to be moving away from the house. I don't want something sloped back into the house. I want it moving away from the house. And if I do that, then any groundwater that might be trapped behind those snow piles really does want to go away from the house. And then I'm less likely to have something like this occur, because if you do take a look right here, you know, we don't have very much height between the ground and the top of that foundation wall. And in some areas, there's even less space. And so if I could even excavate around the perimeter just a little bit to give myself a little bit more space, then that can alleviate the issue. But I really do think the issue is that whenever something lands on one of those logs, it's round and it goes back under, and that's why you see the moisture underneath the house. So that was a pretty cool one. All right, so radon, wow, 42.6, that's pretty high. It's not a record for the year, but it's still really darn high. Or again, anything above 4 pictocuries per liter is gonna be high enough that that's the EPA action level, and you need to have some kind of radon mitigation to take care of this issue. And so, as we said earlier, at the very beginning, you know, we're taking a look at the radon level, we're taking a look at the temperature, we're taking a look at the humidity, we're taking a look at atmospheric pressure, and then that way we can kind of look at everything, and then we can even determine, also with the motion sensor telling us exactly what date, time, whatever, whenever there's an event, we can pretty accurately determine if somebody's been fiddling with the detector or trying to modify the results. Like whenever somebody put it in a refrigerator, it's pretty evident that you put it inside a refrigerator. Whenever somebody opened all the doors and windows to the house and you could see these massive temperature swings of 20 plus degrees, it's pretty evident that you did that. There's a lot of things that happen that basically people are just looking to be a little bit dishonest to save themselves $1,000, you know, because that's how much is a repair? Anywhere from like $1,000 to $2,000 to get radon mitigation. It's just silly. Speaking about silly things, this right here, this exterior fireplace exhaust just cracks me up. Just so impressive, really. The ingenuity on this one is just the best. There are specific UL listed, and if you're unfamiliar with UL listed, basically there's a governing body that says whether or not something will kill your entire family or not, and there are UL listed products that are actually designed to do what this person is trying to do right here. So I'm not saying that this is not UL. I am saying this is not UL listed. This is ridiculous. This is pretty silly. Not only is it silly because of what it is, it's silly because it doesn't do what it's supposed to do as far as like adequately and properly removing stuff from the house, heat from the house, combustion gases from the house. Additionally, you see that the slopes of the grate, if water or anything were to go into there, it would then drop and go in, as opposed to having them like shedding the rain off. So basically, instead of them being, you know, kind of put like this, they're basically open and catching water and then putting it inside. It's silly. So obviously put the correct exhaust flue vent on there, and then that'd be good. All right, winterize. So sometimes we go to houses and we really want to check the water, but the problem is that the house has been completely winterized, or in one of the cases that we were at, the house didn't even have like all the faucets. So if we were to pressurize the system, then we would never have the ability to drain the system. And so whenever there's a house that isn't being lived in and it's winterized like this, we can't test any of the plumbing and we can't turn on the water because steps have been taken above and beyond normal steps of just shutting the water off to do a full winterization process. And we don't want to accidentally freeze pipes and have issues. Check out the pipe freezing video if you have any questions about how pipes end up freezing. All right, this roof had some pretty heavy sagging and it's bad. It's real bad. And the thing is, what I think happened is, I think from heavy snow loads and other things like that, the rafters that are in there just got bent, damaged, cracked, and warped. And that's that. Is it the end of the world? No, it's not the end of the world, but it's just not ideal. And, you know, is it fixable? Oh yeah, totally. Everything's fixable, but you know, who wants to do the work is the question. And so yes, for this house, I would definitely say that whenever it's time to put on new shingles, you need to do some work on the underside of that roof. And that's probably going to be the easiest and most cost-effective way to do that is next time that you replace the shingles, pop the roof sheathing off and then go from there. There is attic access, but you know, getting the length of wood up there to basically sister or resecure those rafters is just not going to happen. So anyway, I think that's the last one. So pretty quick today, but if you have, you know, any questions about the stuff that we talked about, then pretty please reach out to us, because our guys, not only do we talk about all this stuff, but during our in-service trainings, we have a lot of other topics that we end up covering, and they end up taking like 2 to 3 hours, and we do 2 of them now a month. And so, you know, we're talking anywhere from 4 to 6 hours worth of additional training on top of the requirements that we end up doing. And so a lot of training, a lot of knowledge, and home inspecting, there's just so much stuff. There's just so much stuff that we could geek out for a long time. And so I'm trying to just give little tidbits of information without overly doing it, because I could just talk for hours. And this is just like a snippet of the cool things that we find that are a little bit different or just need a little bit more conversation about it. So anyway, hopefully it was educational for you. If you have any questions or if you'd like to schedule a home inspection, please visit 2moosehomeinspections.com. Have a wonderful day.